Part of the game of building more complex systems is to effectively manage their complexity. We really don't want everyone to worry about everything all of the time. So we need to find ways to compartmentalise the systems that we're building and hide some details so that some people can work on their own problems without worrying about what everybody else is doing. This is particularly true for platforms and platform teams. We'd like to provide common functions and services that user-focused teams can rely on to make their jobs easier. But the tricky part is that we like to do this while allowing the people focused on the platform and the people focused on the user-focused apps to make progress in parallel with each other, independently from one another. So how do we insulate these teams from one another? How do we avoid forcing everyone to work in lockstep all of the time? What makes an effective platform that doesn't end up being an unstable bottleneck for changes? Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel. If you haven't been here before, please do hit subscribe. And if you enjoy the content today, hit like as well. I'd like to thank our sponsors, Equal Experts, Octopus, SpecFlow, and welcome our new sponsor, Transfic. Check out this video that describes some of how Transfic work. And please do support all of our sponsors by checking their links in the description below. If you'd like to learn more about structuring teams and software in ways that help us to manage complexity, my book, Modern Software Engineering, describes this in some detail. Check out the links to that in the description below too. A few weeks ago, I recorded this episode, where we discussed the team topologies model for organising teams. In this model, there are four team types: stream-aligned, enabling, complex subsystem, and platform. I rather skimmed over the role of platform teams in that episode, not because they are unimportant, but rather because I had a fair bit more that I wanted to say on the topic. So today I want to explore the idea of platform teams in a little bit more detail. Part of the problem here is that these kinds of team can really liberate an organisation doing software development at scale, but they can also be a big stumbling block if it's not done well. Fundamentally, this is all down to a problem of coupling and how we manage it. And that's one of the genuinely difficult problems in software. There are four aspects of platforms that I'd like to touch on today: the common problems of platforms and platform teams, the principles that matter for success, the strategies that make sense to realise those principles, and some of the tactics that we can help us to achieve those strategies and manage the coupling that is inherent in the use of platforms. There are two very common routes to bad platform code: the ivory tower and the design by accident. In the ivory tower, someone has a grand vision of how life could be easier. This is a good thing, but the way that they implement their vision is usually the problem. They come up with a grand plan and start executing on it. They don't really engage with the users of their notional platform. They don't try their ideas in real systems in real world use. They don't work incrementally in small steps, allowing their implementation and their vision to evolve in the face of reality. Instead, they assume that their vision's perfect and that they need to complete their wonderful platform in its entirety before anyone can sensibly make use of it. This is a big mistake. A good platform is pretty much by definition an exercise in generalizing problems and abstracting to isolate change. I think that you only get to good general solutions like this by working incrementally in small steps and discovering what really works over several iterations in real use. Working incrementally is vital to creating effective platforms that help rather than hinder, in my opinion. As Matt Skelton and Manuel Pais said in the Team Topologies book, the purpose of a platform team is to enable stream-aligned teams to deliver work with substantial autonomy. Their goal is to make stream-aligned teams more effective, The only way that a platform team can do that is by maintaining a laser focus on what stream-aligned teams need and working to prioritize and service those needs. You don't get any of that by ignoring the real-world use and utility of your platform. Your platform needs to solve real problems for stream-aligned teams in a way that makes their work simpler, not more difficult. This rarely, if ever, happens in ivory towers. I've seen examples of ivory tower thinking where the platform team worked for several years in isolation from any real-world use of their code. At the end of this kind of exercise, the code is nearly always a complex, impractical mess. The only way that anyone ever uses it for something real is if they're forced to. Design by accident is common in teams that are trying to improve their code, but can also happen in startups too. Teams often adopt some sort of organising principle for breaking up their systems, maybe using nouns and verbs to identify classes or bounded contexts for service boundaries, something like that. But then, often, there's a load of stuff left over that didn't fit into their division, that doesn't seem to have a natural home. This is often grouped together into something that we call the platform or maybe common services, and this is usually a kind of random collection of access points to data or other services, and a random-ish collection of technical things that seem general and useful, logging, authentication, authorization, and so on. The kind of stuff that nearly every app or service needs, but you don't really want every app or service team to write for itself. These are often grouped together into the platform, even though they aren't obviously directly related to one another. This is usually driven by the goal of striving to maximize reuse, or to put it another way, to implement dry. The problem with dry as a guiding principle is that while it's a good rule of thumb, it's not a great global strategy because the cost of perfectly dry code is increased coupling. None of this is evil or even wrong, but it does represent a kind of slippery slope. It's very common for such platforms to become development bottlenecks. Team A requests a change in the platform. They're blocked until the change is made. The platform team works on the change, but when the change is made, teams B and C are forced to update and retest their code to accommodate it, often even when the change is of no use to them right now. This is developmental coupling. Everyone is forced via the platform to make their change in step with everyone else. A can't release their new feature until teams B and C and the platform team have all finished their changes. This is a dysfunctional platform, really. So what are the principles that we should be striving for? As I already said, I do like the team topology's focus. Platforms should always make life easier for stream-aligned teams, not necessarily in naive ways, but in strategic ways. It's okay for a platform to ask for a little bit extra work if it's able to hide lots of work behind the scenes as a result. For example, a platform that hides regulatory compliance from a development team is a very good thing, even if it means that you have to tell it who's making a change and what the change is about. But if we're going to do this kind of thing, we'd like to be able to tell the platform the bare minimum that it needs to know to be able to hide the work. One very important way to do this is to take extra care about the impact of coupling. The most effective way to build software in large teams is to allow each team to make progress independently of others as far as you possibly can. This is facilitated by technical and organizational choices. Our aim should be to maximize the ability of teams to make progress independently of one another. It's a big problem if every change to our system demands that several teams need to coordinate their work to achieve it. It's much more effective when teams can make progress independently. This means that we need to select the boundaries between our teams with some care, and we need to be willing to invest to some extent in our ability to retain this independence. That means we need to be willing to accept some extra costs in our design, as long as those costs allow us to work more independently. So adopting, for example, a ports and adapters approach to implementing conversations between modules or services is often a good idea. Picking nice abstractions that insulate our assumptions from the implementation detail of other parts of the system, and designing software with a good separation of concerns are all good technical techniques that enhance the independence of the software, but even more crucially, support the independence of the teams that create it. Platforms and platform teams are crucial in this respect, but also particularly challenging, because they tend to be points in our design that concentrate coupling. Platforms then demand that we should be a bit more strategic in our design choices and more cautious to avoid quick and dirty hacks to help a streamlined team make short-term tactical progress. Platform teams need to be extra cautious about the degree to which APIs expose implementation decisions. A starting point for a platform team can be something incredibly simple. Maybe even just documentation that describes how to add a new service or organize a directory structure to make it easy to find tests. But even at this level, the aim is for these decisions to be a little bit more stable, to change only when they really must, and where possible, to be heading in a direction that we guess future versions of the platform will benefit from. So a key mindset for platform design is that a change is somewhat expensive here. We need to insulate our users from change and figure out how to minimize its impact. One route that helps is to focus on ease of use from the perspective of consumers of the platform, even if that means doing a little bit more work in the platform code itself to make it easy to use. Ease of use is a key attribute for these parts of a system. This means that a good design at these points is important. Good platforms are self-service from the perspective of a streamlined team. This combination of a need for ease of use and appropriately loose coupling means that it's vital for platform teams to design their APIs from the perspective of their streamlined users. This is the real root of the problems caused by ivory tower design and design by accident. In neither case are the platform designers thinking clearly enough about their users' experience. A great platform gives you access to services and behaviours that you don't need to fully understand, and certainly don't need to know the details of how they're implemented. They should keep secrets from the code that uses them. Over the years, I've come to the conclusion that the idea of user stories is a kind of shorthand for something that may be a bit more important. Often, when someone in a platform team hears user story, they think that means imagining the end user using some application that uses your platform. This is often not terribly helpful, particularly if your platform is several layers deeper than the end user features. For a platform, part of the challenge is that your users are other pieces of code, or rather the developers of other pieces of code. The big trap for most software developers is that there's a lure to confuse their focus on implementation detail with requirements. Good software comes from teams that are able to clearly separate what the system needs to do from how it achieves it. When our users are end users interacting with our system through some UI, maintaining the focus on the difference between what and how is tricky enough. When our users are other programmers like us, it's all too easy to slip back into bad habits. We end up designing the code from the inside out rather than the outside in, focusing on implementation detail rather than the outcomes that our system needs to achieve. The external public interface to our platforms and how it insulates users from detail and change in the platform is a primary design concern, or at least it should be. Getting this right matters even more for platform code if we are to keep the coupling demons in check. It's my view that platform teams should take a very strict, very disciplined approach to the design of each feature that changes the API, and always do that wholly from the perspective of users of the platform. This makes the platform more focused on the outcomes rather than the implementation, and it focuses us on the design of the APIs and their ease of use from a user's perspective. All of these things help us to achieve nicer, more generic, simpler APIs. The next part of the problem is really about effective change management. And yet again, this is all about managing coupling. As a platform team, our goal should be to never, or at least almost never, force change on stream-aligned teams. For this, there are two broad techniques and then some tactical details. Broadly, we can work in ways that allow us to change our API without forcing stream-aligned teams to change their code. That means loosely coupled approaches to API design. Or we can work in ways that allow us to keep things working when we change our platform API. We take the responsibility to change all of the consumer's code that uses it. That's it. There are no other options. Let's look at the second option first because it's a little bit simpler to think about. If I have an API and I want to change it, when I commit my change, it may break your use of my API. So now, after my commit, our combined system is broken until you fix your use of my API. Continuous integration and shared code ownership allow us to address this problem directly. I commit my changes and the build fails because your code no longer works against my new changed API. In continuous integration, the committer is always responsible for any trouble that they introduce. So now, this is my problem. I need to either revert my change and think again, or fix your use of my API. This works for even tightly coupled APIs as long as the feedback from continuous integration is fast and clear enough. It also scales surprisingly well too. The alternative requires better design, but it ultimately scales even better. In this case, my objective as a platform developer is to make changes without ever forcing any change on you. So my API needs to hide lots of detail. And I'm going to need to be extra cautious of some kinds of change and aware of the kinds of change that are likely to be more problematic. There are a variety of approaches to this, and some technical choices make this kind of thing more difficult than others. Let's look at some examples. Imagine we have some hardware that generates some binary data. We could write a simple platform API that interfaces to the hardware and passes the binary data to consumers of the platform. So now, all of the apps consuming this service need to understand the format of the binary data. If the next version of the hardware changes the binary format, everything stops working. We could insulate applications that consume this platform service in a variety of ways. One simple approach would be to version the API. So version 1 of the platform API generated our old binary data stream. Now the new version of the platform adds a new API that exposes the new binary data. But it also retains support for the old version too. In this case, we add a little translator that translates the version 2 binary data from the hardware into the old version 1 format that we can present through the old API. This is more work. It's a support burden in the platform, but it retains backward compatibility from version 2 to version 1. There's another, less coupled approach that we could take. Instead of exposing the binary data, we could always translate and expose an abstraction of some kind instead of delivering the raw binary data to each of the apps, requiring them to understand its format. So if our data represented a book or an account, the platform would define a data structure that represents a book or an account and return that. Now, if our binary format changes, all changes happen only inside the platform, so our apps are stable. All of the apps keep working completely insulated from the hardware change. This is great, up to a point, but if we need to change the representation of the book or account, once again, all apps need to change in step unless we version these APIs too. So the next step is to adopt some maybe more flexible representation than a fixed data structure. Some more dynamic messaging form, perhaps. JSON, XML, YAML, something like that. Now we can add things to the data structure, and as long as our apps are written thoughtfully and only care about the values that they rely on to work and ignore everything else, everything keeps working, even when we add new fields to the messages. But even here, there are some kinds of change that are more disruptive than others. Changes in nesting and structure or deletions are more complicated than additions, for example. So we'll have to be extra careful for those kinds of change. We may still have to support multiple versions of even these more flexible APIs to retain the independence of the teams and the software. My point here is not to give an exhaustive list of the techniques of flexible API design, but rather to point out what I think are a couple of really important ideas. APIs in general and platform APIs in particular are important places in our code. They demand us to be more cautious at these points in our designs, because the cost of changing these parts is more than changing only implementation detail, or it should be. I would argue that maintaining our ability to change our code easily is a key attribute of good design, and one that in particular liberates the value from platforms. This means that platforms very rarely work well if they are dumb pass-throughs for data. That only makes sense if the format of the data as it's consumed by users of the platform is completely static. The format of the data that you expose through the platform is as much a part of the exposed API as the function calls or messages that the platform supports. Good platforms almost never force change on their users, and good platform teams do extra work to reduce the chances of forcing changes on others. Tracking breaking changes, maybe adding contract tests to highlight them. Recognizing the significant extra costs of an overly coupled platform is important, and working to always mitigate the costs of that coupling is part of the role of an effective platform team, as well as removing work and hiding complexity from stream-aligned teams. Thank you very much for watching.